Hi, this is Jason Baker. Welcome back to our lecture. Let's talk a little bit about shell scripting. We've talked a bit about automation so far and the benefits of automating our processes and some of the methods or principles that we might want to follow when trying to automate processes within our organization. Shell scripting is a very common way to automate processes. And shell scripts are basically um, sort of like small, very simple programs. They're written in a procedural way. So you can think of a shell script as performing a set of tasks that are interpreted and executed by our operating system. A shell script is a file that it's a text file that groups together a set of commands, and the the shell interpreter runs these commands in a batch, starting from the commands at the top of the file all the way to the commands at the bottom of the file. And you'll find that shell scripts are supported by a variety of different operating systems. Certainly Linux operating system where they're used extensively. You also find shell scripts on Windows and Mac OS. If you're working in a company that's using Windows, you've probably seen PowerShell scripts. Those are shell scripts, just like the scripts that we'll be writing and using in this course. We're going to focus on Linux shell scripts in the course, of course, because Linux is the primary operating system that we're going to be using. And when we're writing shell scripts on Linux systems, we use something called the bash shell. And the bash shell is a command interpreter. When you log into or remotely access a Linux system, the operating system places you into the bash shell. You'll see a command prompt and you'll see your cursor. You can type in commands on the screen. Those commands are being executed by the bash shell. The bash shell has been around for a long time. It was a free open source replacement for the Bourne shell, which was a shell that has been around in Unix systems for decades. Bash was released in 1989, and it's typically the default shell that you'll find used in most Linux distributions. So again, what is a shell? The shell is this interactive command line processor that you're going to use that will run commands that you type in when you are logged into a Linux environment. You'll find that you can run commands manually on the shell's command line, or you can take those same commands and put them into a text file called a shell script file. And then you can tell the shell interpreter to read the commands and execute the commands from that file. The shell script basically allows you to do everything that you could do from the command line. So all those commands that you type in manually in the command line can be placed into a shell script. And the shell script will then run those commands, starting from the very top of the file and then progressively running each command until it reaches the end of the file. Here's an example shell script. This is a very simple script. And of course, we're going to start with something simple. In this case, it's a hello world type of script. One thing I should note is that when you're creating a shell script, you're writing code. But shell scripting is not like a full-blown programming language. So if you're familiar with a programming language like Java or Python or Ruby or JavaScript or something else, it, these shell script constructs will look familiar to you, but it's important to note that a shell script is not like a full-blown programming language. If you're one of those people who, is not totally comfortable writing code, or you're not really a software developer, you might be an aspiring software developer, but you're not really a professional developer yet. Don't worry, because shell scripting is really easy to pick up. It's not like a full-blown programming language, and the shell scripting uh, techniques and features that I'm going to talk about in this lecture are the only ones that are required within this course. Okay, so that being said, let's look through this simple shell scripting example script. We'll go line by line. This first line looks a little weird to most people that aren't familiar with shell scripts. And the way we read this line is we call this the shebang bin bash line. It starts with this hash character and then an exclamation point, which we call the bang character, /bin/bash. This first line is really important. This line tells the shell interpreter that the contents of this file should be executed by the shell interpreter. In other words, this line designates this script file as a shell script. So it's very, very important that your shell script file begins with this line. The second line says echo hello world. The echo command is like a print command. It outputs this text in quotes to the terminal display, or what we call the standard output. And then the next line is another echo line. Again, echo is like a print command. In this case, it's going to echo out, these are the current files, and then it has this sort of strange looking $PWD. Well, anything that starts with a $sign in our shell script is going to represent a variable. In this case, this is a special variable which tells the interpreter to print out the current directory that the user is working in. Next, the script runs the ls command. The ls command tells the interpreter that it needs to list out the files in the current working directory. And then finally, we have this exit 0 command. That tells the interpreter that this is the end of the shell script. It should stop the execution of the shell script and should exit with a 0 value. The 0 value signifies the error code, the exit error code for the script. And 0 means that the script executed properly. This exit command is optional. Typically, it's nice to have because it's sort of you're specifying that you want to cleanly exit from the script. But if you don't include this exit command, then the interpreter will automatically exit the script once it reaches the end of our shell script file. Okay. So let's look at some of the features of this shell script in more depth. And we'll start by looking at variables within shell scripts. So shell script variables act like the variables that you find in most any typical programming language, with the exception that shell script variables are not typed. So we use a shell script variable to store some sort of value. And shell script variables don't have a type. So there's no such thing as like a string or an integer or a character shell script variable. We just create a variable and we can assign whatever type we want, basically, to that variable. To define a variable in a shell script, we use this particular syntax here, where we have x equals some sort of value, where x is the name of the variable and value is the value that we want to associate with that variable name. Notice here that there are no spaces between the x and the equals character or the equals and the value. That's important. One of the trickiest things to learn about shell scripts is that shell scripts can be very, very picky about white space and about spaces between different like assignment characters and between different evaluation strings and so on. So spaces matter. Spaces are really, really important. And so how do you know where to put spaces? Well, you listen to lectures like this and trust me, when you define a variable, you don't want to have any spaces between around that equal sign. The other rules we'll learn along the way here. One of the common practices in shell scripts is to capitalize the variable name. The shell script is case sensitive. Most everything in Linux is case sensitive. I've already mentioned in this course that case matters. So you can't interchange lowercase and uppercase variable names. They reference two completely different things. It's very common in shell scripts to capitalize variable names. It's not a requirement, but it's just a common practice. When we want to refer to the value of this variable later on in our script, we can reference that variable value using the $ variable name syntax. You saw how that was used in the earlier script where we had this $pwd. If we reference the variable, we precede it with a $ in our script, and that will reference the value of that variable. And then one other note about variables is that if you wrap a variable in single quotes, it's going to have a different meaning than wrapping a variable in double quotes. So here are two examples. If I run the echo command and I echo user, but wrap $user in single quotes, then that's telling the interpreter that I want to literally print out the text $user. In other words, the interpreter will not try to reference the value of this variable. It doesn't see this as a variable. It sees this as a literal string, which makes sense, right? There are times where you might want to print out something with a $sign in it, and you wouldn't want the interpreter to think that everything with a $sign is referencing a variable. If it's wrapped in single quotes, then the interpreter looks at this value literally. if I reference a value, if I try to echo out or print out a value that is wrapped in double quote characters, then the interpreter will interpolate this value. In other words, it will reference this as a variable, determine the value of that variable, and output that value to the standard output. It's very important. Single quotes versus double quotes. They have different meanings when they're used within shell scripts. One of the other kind of weird things about shell script variables is that the interpreter will replace every occurrence of a variable with its value in the script. And this is where shell scripts kind of diverge a little bit from our traditional programming language, because you would really never see this sort of behavior in something like a Java application. Let's walk through this short little example script and see what's going on here. So we start out the script with our shebang bin bash statement. That tells the interpreter that this is a shell script that it needs to execute. On the next line, we are creating a variable called ls, and we're assigning that variable the value ls, lowercase ls. Next, we create another variable called ls underscore flags, and we assign that variable the value -al. And then finally, we have this statement here that the interpreter is going to execute, but the statement seems a little bit weird to us if we're accustomed to traditional programming languages, because in this case, the statement consists of two variable references. And your typical programming language would, generate some sort of compiler or interpreter error if it ever saw this sort of statement. But the shell interpreter can deal with this just fine, because what the shell interpreter will do is that it will replace this variable reference with the value, in this case ls. It will replace the second variable reference with its value, in this case -al. Once it's replaced these references with their values, then it will try to execute the statement. In this case, it will execute the statement ls space -al. And the ls command, as you learned earlier, is the command that we use to list the directory contents of our current working directory. So a really interesting, very powerful, but also potentially very dangerous way that the shell interpreter deals with replacing the value of variables. What if somebody could change the value of ls and set it to some other command that is potentially very destructive on our system? I just wanted to make the point that the interpreter will literally replace this value within command lines, and then it'll run the command. So it's a very, very powerful feature. What happens if you need to display a variable, the value of a variable, and you need to sort of concatenate it with other characters? Here's an example where I want to echo out the value of the name variable followed by the characters x, y, z. Well, if I ran the command like this, what's going to happen is that the interpreter is going to look for a variable called name xyz, And it's probably not going to find that variable. My intention is that it should find the value of the name variable and then concatenate it with XYZ, but that's not what it's going to do. In order to accomplish that, what I need to do is I need to essentially protect this variable name. I have to sort of fence it off from the surrounding text characters. And I do that by surrounding the variable name with these curly braces. So now the interpreter will find the value of the variable called name, and when it prints it out, it'll print out that value followed by X, Y, and Z. When uh, when we're using shell variables within our scripts, one of the nice things that the interpreter does for us is that it's got all these sort of built-in variables that we can reference within our script. Oftentimes when we're running a script, we're passing in sort of arguments, additional parameters and attributes into that script. Here's an example where we're running a script called script name, and then we're going to pass in some additional arguments into that script. This example is maybe I have a script called create report. I'm going to run the create report script. I'm going to pass in two arguments. I'm going to pass in orders. I'm going to pass in 2017. Well, how do we reference these arguments within our script? The cool thing is that shell interpreter automatically creates these sort of built-in variables and associates those variables with the argument values that we provided to the script. In this case, the shell interpreter creates a series of numbered variable names, starting with $0. $0 will reference the actual script name that was used to run the script. $1 references the value of the first argument passed into the script, in this case, orders. $2 references the second argument, which was 2017. We can use the $hash variable name to determine the value of the number of command line arguments passed into the script. In this case, $hash would contain 2 because I passed in two different arguments, orders and 2017. There's all sorts of other built-in variables that we can reference within the script. Things like $home to get the home directory of the current user. You saw me use $pwd to get the current working directory earlier. There are dozens of different built-in variables that are available, and these are all made available to us out of convenience and because these are frequently used variables within our shell scripts. So I mentioned that a shell script is going to execute commands in the shell script text file, starting at the very top and then going command by command all the way down to the bottom. Well, there might be times where we want the interpreter to run sets of commands conditionally. In other words, we want the shell interpreter to run some commands but not others, depending on some sort of condition or depending on some sort of argument that is passed into the shell script. Just like any programming language, we can conditionally run commands using if-then-else statements. The syntax for an if-then-else statement in a shell script looks like this, where we have if some condition that's evaluated, if this condition is true, then execute a block of statements. We can include else if statements. So if this condition is not true, then evaluate this condition next, and then run these statements if that's true. If that condition isn't true, then we can default to an else block where it will finally run all of these statements, and then the if then else structure is ends with the fi syntax. You notice that fi is just simply if backwards, and which seems a little bit funny. You'll see this convention in other cases with shell scripting, where you have this sort of block of statements, and in this case it starts with if, and then it ends with if that's spelled backwards. So one of the key things to understand in these if then else statements is this condition statement. This is, sometimes we call this the condition test. The way we write this condition test is in this particular this syntax, where we create the test within these square brackets. We have an operand, and then an operator, and then a second operand. This is where we're doing some sort of comparison between two operands. We're trying to see if one variable is equivalent to another variable, or one variable might be greater than or less than, and so on. Here are some examples of how we might create this condition test. The first example is if we have a variable x, we're going to see if it's less than, using the -lt, less than the value in the variable y. The next statement does a test to see if the value, or if the variable x, if it contains an empty value. That's what the -n is testing for. It's saying if variable x is not empty, if it contains some sort of value, then this statement it would evaluate to true. The opposite of that is the next test, where we're testing to see if the variable x contains an empty value. So we're testing to see whether or not the variable x has been set to some sort of value. That's what the -z test is doing. And then finally, we're testing to see, in the last conditional test, to see if the value of variable x equals the value of variable y. One thing that's really important to note is that the spaces you see here in these brackets really matters. Super important. These tests will fail if there isn't a space between the left square bracket and the first operand or operator. And then also there needs to be a space afterwards as well. This is another case where we saw earlier, where we were looking at variable assignment. You needed, that had to have no spaces. This is a case where spaces must exist within this condition statement. Very, very important. Okay, so we looked at a condition statement. One of the other common things that we might want to do in a shell script is loop over a series of commands multiple times. It's very, very common, to do sort of iterative loops within the software that we're developing. In the case of a shell script, there are a couple different ways that we can iterate over a series of commands. One way to do that is using a for loop. And to do a for loop, we follow this syntax. We say for some sort of argument in a list, we want to do, or we want to execute a block of commands. And we end the for loop with the done statement. This for loop looks a little bit different than your typical programming language. Here's an example. We're going to say for a planet, in this case, the planet is a variable name. For planet in a list of planets, and our list includes Mercury, Venus, Earth, and Mars, we want to execute this block of statements. In this case, there's only one statement, and the interpreter is going to print out the value of the variable planet. Each time the interpreter loops through the set of statements, the value of the planet variable is going to be associated with each item in the list that's provided. So we use for loops to iterate over lists. Another method that we can use to iterate over a block of commands in a shell script is to use a while loop. And what the while loop will do is it will evaluate a condition, and while that condition is true, the interpreter will run a block of commands that are listed in this do and between the do and the done statements. Here's an example. We have shebang bin bash. We're going to set the value of the variable x to 0, the value of the variable y to 5. And then we're going to say while the value of variable x is less than the value of the variable y, we're going to run these two commands. So we're going to print out the value of the variable x, and then we're going to increment, that's what the let command is doing. We're going to increment the value of the variable y, the variable x. So x is going to equal whatever its current value is plus 1. This script will then print out, it'll print out 0, then 1, 2, 3, and then 4. Once the value of x equals 5, then this while condition will no longer evaluate as true. And so this block of statements will run and the script will simply exit out. The for loop uses a list, and the while loop evaluates and iterates based upon some sort of condition.